Okay, we're going to look at some math review. So quick review here. When we're working with units, if you're going from smaller units to larger units, always divide by the appropriate factor of 10. So an example, 0.001 kilograms equals 1 gram, which also equals 1,000 milligrams, which equals 10,000 micrograms. If going from larger units to smaller units, multiply by the appropriate factor of 10. So looking here, 1 milligram is equal to 0.001 gram. 1 milligram is equal to 1,000 micrograms. 3.14 micrograms is equal to 0.00314 milligrams. And 26 milligrams is equal to 0.026 milligrams. And so for me, it's often just simply moving the decimal point appropriately. So we've talked about drug calculations ad nauseum in past lectures, and when we're looking at drug calculations, we're looking at weight multiplied by the dosage equals the dose. So it's typically kilograms multiplied by mg per kg equals the milligrams that we need to administer. Then we start looking at the number of tablets or the number of mils that we need to give the patient based on the dose. So dose divided by concentration equals the mass, if we're talking about tablets, or the volume, if we're talking about liquid. So milligrams divided by mgs per tablet equals number of tablets, and milligrams divided by mgs per mil equals number of mils. So practical example number 1. Sasha Velour is a 25-pound dog with an abscess. The vet requests that you administer a dosage of 22 mg per kg. The clinic has 500 milligrams scored tablets in stock. What is the dose and how many tablets will you administer? So number 1 step is we have to convert the pounds to kilograms. So we divide 25 pounds divided by 2.2, and that gives us 11.36 kilograms. Step number 2, the veterinarian has asked for a dosage of 22 milligrams per kilogram. So we have to multiply 22 milligrams multiplied by 11.36 kilograms, which gives us 249.92 milligrams. So there we go, we've got our dose. How many tablets will you administer? So our clinic has 500 milligram scored tablets in stock. So with that, the patient needs 250 milligrams if we round it, and the clinic has 500 milligrams scored tablets. Now, because they're scored, that means that we're allowed to split them. It means that the company that produced them can essentially guarantee that there is equal amounts of the drug on either side of the tablet. Therefore, the dose is 250 milligrams, and the patient needs half a tablet per treatment. Practical example number 2, Acid Betty is a 32-pound dog with a painful leg. The vet requests that you administer a dosage of 0.5 mg per kg hydromorphone intramuscularly. The clinic has 10 mg per mil hydro in stock. What's the dose? How many mils will you administer? Well, first step, of course, we need to look at 32 pounds. How many kilograms is that? We need to divide 32 pounds by 2.2, and that gives us 14.5 kilograms. Then we need to figure out the dose. So it's 0.05 mg per kg, and we have 10 mg per mil. So let's start with 0.05 mg per kg. So we're going to take 0.05 milligrams, multiply it by 14.5 kilograms, and that gives us 0.73 milligrams is the dose. Now, how many mils will we administer? So now we have the dose. We need to divide it by the concentration of the drug. The clinic has 10 mg per mil hydromorphone in stock. So we're going to take 0.73 milligrams and divide it by 10 mg per mil, which gives us 0.073 mils, which we're going to round to 0.07 mils. So the dose is 0.73 milligrams, and we administer 0.07 mils. All right, Jada Hall is 13 pounds. The vet instructs you to use Propofol at a dose of 4 mg per kg. The concentration of Propofol is 1 gram per 100 mils. How many mils of Propofol will I draw up? Step 1, 13 pounds. We have to divide it by 2.2, and that gives us our kilograms. So 13 pounds divided by 2.2 is 5.9 kilos. Step 2, we have to figure out our dose. So our dose is 4 milligrams per kilogram, and our kilograms is 5.9. So we're going to multiply 4 by 5.9, and that gives us 23.6. And of course, we can cancel out the kilograms. So we know that we need to administer 23.6 milligrams. Next step, the vet has told us that it's a 1 gram per 100 ml solution. We know that 1 gram equals 1,000 milligrams. So my next step here is going to figure out the mgs per mil, because that's a workable solution, because then we're working with the same units. We're working with milligrams. So I'm going to take my 1,000 milligrams and divide it by the 100 mils to figure out our concentration in mgs per mil. So I take 1,000 divided by 100, and we've got 10 mgs per mil. All right, so here we have a 10 mg per mil solution, and we know that we need 23.6 milligrams. So we're going to take the 23.6 milligrams, divide it by 10 mgs per mil, and here we have a repeating milligrams, so we can cancel the milligrams, and we're left with mils. So we have 2.36 mils. So therefore, we will draw up 2.36 mils of Propofol. All right, percent solutions. We started talking about this last semester. So it's a variation on liquid drug concentrations, and we have 3 forms. We have weight by volume, which is the number of grams of drug dissolved in 100 mils of liquid. We have volume by volume, which is the number of mils of drug per 100 mils of liquid, so drug plus medium. And we have weight by weight, so the number of grams of drug per 100 grams of drug plus medium, so it's powder or liquid. So examples, a 10% weight to volume solution is 10 grams per 100 ml, which equals 10,000 milligrams per 100 mils, which ends up being, if we divide 10,000 milligrams divided by 100 mils, we have 100 mg per mil. 33% weight to volume solution, 33 grams divided by 100 mils. We have, if we change that to be on workable terms with milligrams, then we have 33,000 milligrams divided by 100 mils equals 330 mg per mil. If we have a 4% solution, weight to volume solution, we have a 4 gram per 100 ml solution, which means we have a 4,000 milligram to 100 ml solution, which equals a 40 mg per ml. And generally, we're talking about a weight to volume solution. So a really quick way, you guys explained this last semester. If you were in my class, you guys are totally on this. If we're looking at a weight to volume solution, so basic weight by volume solution, you can always get the quick concentration level by adding a 0. So if we're looking at a 10% concentration, we're looking at 100 mg per mil. If we're looking at a 33% solution, we're looking at a 330 milligrams per mil solution. Okay, converting mgs to mil. We've got 2% solution is a 20 mg per mil. 10% solution is 100 mg per mil. 5% solution is a 50 mg per mil. Easy peasy. So looking at percentage solutions for practical anesthesia. Your canine patient weighs 4 kilograms, and you've been requested to draw up 2 mg per kg lidocaine 2% weight to volume solution to perform a local block for a mass removal. How much lidocaine will you draw up? All right, so our dose is 4 4 kilograms multiplied by 2 mg per kg. So we know that our dose is 8 milligrams. So that patient needs 8 milligrams total of lidocaine. Mg per mil, well, we know that lidocaine is 2% solution. So quick and easy way, we just add a 0 and it's 20 mg per mil. Very easy peasy way to look at it. If we want to work it out to identify the math, a 2% weight to volume solution is 2 grams per 100 mils, which equals, if we bring it down to a milligrams per mil, it equals a 2,000 milligram per 100 mil solution, which when we divide that out, it's 20 mg per mil. So then now we know that the patient needs 8 milligrams and we have a 20 mg per mil solution. So we're just going to do simple division. 8 milligrams divided by 20 mg per mil. We can cross cancel the milligrams and we're left with mils. The answer there is 0.4 mils of lidocaine. So we'll draw up 0.4 mils of the 2% weight to volume lidocaine for a dosage of 2 mg per kg. Carrying on, your 12 kilo patient is having a dentistry. The vet requests that you place 6 dental local blocks using 0.5% bupivacaine. The total dosage is 2 mg per kg. How much bupivacaine in mils will you administer to each dental block location? Gosh, we had to make it harder. Step 1, 0.5% solution is a 5 mg per mil solution. Step 2, we have our order. So 12 kilograms, and we're going to use 2 mg per kg. So we're going to take 12 kilograms, multiply it by 2 mg per kg, and that leaves us with 24 milligrams. So we know that in total, the patient needs 24 milligrams of bupivacaine. Step 3, we're going to divide 24 milligrams, which is our total dose, divided by the concentration. So we have 24 milligrams divided by 5 mg per mil, gives us 4.8 mils. Now we know that we need to divide this into each dental block location, and we have 6 dental block locations. So step 4 is we're going to take 4.8 divided by 6 locations, and that gives us 0.8 mils. So we can draw up 0.8 mils per each dental block location. All right, and then we'll lastly go through reconstituting powders. So of course, as always, read the labels on powders carefully. Some powders require specific reconstitution concentrations in order for it to be stable for an extended period of time. So always read the instructions, and if they have specifics, then certainly use the specifics that they recommend. Use sterile water to reconstitute. Use an aseptic technique, because you have to remember that we're creating a mass amount of drug that could be used for intravenous use, so we have to ensure that it is aseptic. Shake the bottle very well to dissolve all of the crystals and granules completely. Let sit or tap gently to eliminate bubbles in the solution, and the powder will dissolve better in room temperature sterile water rather than cold sterile water. And then, of course, label the vial after reconstitution. So nobody knows what concentration that solution is except for you when you make it up. So you need to seriously communicate that to others. So you're going to label the vial with the drug name, the concentration that you've made it up to, the date and time of reconstitution, the expiry, and your initials. So I write the date and time of reconstitution because, again, like I just said, certain drugs allow you to reconstitute at certain concentrations for it to be stable for a certain period of time. It seems like a lot of unknowns. But essentially, if the drug label says that if you create this in a 5 mg per ml solution, it's going to be stable at this concentration for 36 hours. So if you vary from that and you decide to create a random concentration that suits your needs more than the product's needs, it just means that you might have to throw it out sooner. Okay, so let's look at reconstituting powders for practical anesthesia. Your 20 kilogram patient is being admitted for joint surgery. You need to treat him with 20 mg per kg cefazolin IV at the start of surgery. You have a 500 milligram per vial cefazolin. How will you reconstitute it to use it for treatment? So number one, what dose does the patient need? Well, we know that we need 20 milligrams per kilogram, and we have a 20 kilogram animal. So we're going to multiply 20 mg per kg by the 20 kilograms itself, and we get 400 milligrams is the amount that we need. Step number two, how are we going to reconstitute? Ultimately, the volume per mil is your choice. So you want to make it a manageable amount to mix in the vial, draw up, and administer. So for this case, we're going to choose to add 5 mils to the vial. So if we add 5 milliliters of sterile saline to a 500 milligram vial, we end up with 100 mg per mil. So we take that 500 milligram vial, divide it by 5 mils that we're adding to the solution, and it creates 100 milligrams per mil. So of course, what volume will we draw up for the dose? We're going to divide that, the 400 milligrams divided by 100 milligrams per mil, and that gives us 4 mils of cefazolin to be given intravenously. All right, we have a 1 gram per vial thiopental, and you want to make up a 2% weight to volume solution. How much sterile water will you add to the vial to achieve this? Let's have a look. All right, so we can take it, we have two ways. We can cross multiply, or I can work it out. I'll show you the way that I typically do it. So cross multiplication, we can take our 1 gram over an unknown amount of milliliters is equal to 2 grams over 100 milliliters. So when we cross multiply, we get 1 gram multiplied by 100 mils equals over the 2 grams equals how many mils? So if we take 100 mil divided by 2 grams, it gives us 50 mils. So that's one way to do it. For me, I find it a little bit simpler not to cross multiply because my brain doesn't work that way, and that's okay. So for me, what I would do is take 1 gram, and I know that 1 gram equals 1,000 milligrams. And I know that a 2% solution equals 20 mg per mil. So then what I will do is I'm going to divide 1,000 milligrams divided by 20 mg per mil, and that gives me the same answer at 50 milliliters. And I think this is the key here with math. Everybody's going to do math a little bit differently. And truly in the end, I don't really care how you get there. It's getting there that is the answer. And then, of course, looking back at how you got there, and if you got the right answer versus the wrong answer, understanding where you may have made an error in your process. So next example, or is this the same? There we go. Now, okay, so now we have a 12 kilogram patient that we want to anesthetize with a 2% thiopental solution at a dose of 12 mg per kg. How much thiopental will you draw up in a syringe? So first off, I'm going to convert 2% weight to volume solution to a mg per mil, and then we'll get our dose and our volume. So 2 grams divided by 100 milliliters is 2,000 milligrams per 100 mil. So then, of course, we get 20 mg per mil. So we know that 2% solution, weight to volume, is a 20 mg per mil solution. To get our dose, we're going to multiply 12 kilograms by 12 mg per kg, which is 144 milligram. And then to get our volume, we're going to take our 144 milligrams divided by the 20 mg per mil, and we have 7.2 mils. So this is how you might be able to see using this sort of practical math from start to finish when we're working with anesthesia. Sort of creating the solution itself, figuring out the dose, and then of course getting the dose specifically and the amount from that concentration that you created. Okay, reconstituted powders continuing. So you have a giant breed dog that weighs 128 pounds, and you want to anesthetize with 2% thiopental at a dose of 12 mg per kg, dosage of 12 mg per kg. From experience, you know that this will be a really large volume of the drug, so you want to decrease the volume of thiopental needed for injection. To do this, we'll need to increase the concentration of the solution. So let's say normally we make a 5 mg per mil solution. We want to increase that concentration significantly so that we're not giving heaps and heaps and heaps of the drug. We're not drawing up all that amount. So you have 1 gram of thiopental powder per vial and you want to produce a 4% solution. How much diluent will you need to add? So 1 gram per vial of thiopental, you want to make a 4% solution. How much sterile water will you want to add to the vial to achieve this? So a couple different ways to do it. 1 gram over questionable amount of mils equals 4 grams over 100 mils. Then we're going to multiply. So we've got 1 gram multiplied by 100 mils divided by 4. Essentially, we're saying 100 mils over 4 is 25 mils total. Alternately, the way that I do it, because I don't like cross multiplying, is 1 gram equals 1,000 milligrams. And I know that a 4% solution equals 40 mg per mil. So 1,000 mgs divided by 40 mg per mil equals 25 milliliters. So I'm going to add 25 milliliters. So now I have to anesthetize my 128-pound patient with a 4% thiopental solution at a dose of 12 mg per kg. How much am I going to draw up in a syringe? So first, check your units, convert 4% to mg per mil. 4% is 40 mg per mil, and then convert 128 pounds to kilograms. So I'm going to divide 128 pounds divided by 2.2, which equals, I don't know why my math looks funny there, but dividing 128 by 2.2 equals 58.2 kilograms. Next step, 58.2 kilograms. We're going to multiply by the dosage of 12 mg per kg. So that equals 698.4 milligrams. So that animal's dose is 698.4 milligrams. So now I've made a 40 mg per mil solution, right? I've got a 4% solution. And I need 698.4 milligrams. So I'm going to take 698.4 milligrams and divide it by my 40 mg per mil solution. And that leaves us with 17.46 mils. So that's a 4% solution. We could increase the percent solution if we want to give a smaller volume. So we could make it a 10% solution to give a smaller volume in the end, etc. So if that were the case, if we did a 10% solution, we would take our 698.4 milligrams and divide it by 100. So I'm going to do that in my calculator because I never trust my head with math. So 698.4, if we were to take a 10% solution, which is 100 mg per mil, it'd be 6.98 mils. So you can see how we can play with the total volume that we need to give by adjusting the percentage of solution that we create. Bowser's a 13 kilogram dog, and the vet asks you to administer a 20 mg per kg dose of IV ampicillin antibiotic. You have 1 gram vial of ampicillin. You reconstitute the powder with 5 mils of sterile water. How many mils will you draw up to administer? All right, so looking at our startup with this, 1 gram equals 1,000 milligrams. And we know that we've reconstituted the powder with 5 mils of sterile water. So we're going to take 1,000 milligrams divided by 5 mils. So we have a 200 mg per mil solution. 200 mg per mil solution, which is a 20% solution. So how many mils now will we draw up to administer? Well, we know, oh goodness. So we know, I don't know why I didn't write this out for you guys, sorry. We know that we need we have a 13 kilogram dog, and we need to administer 20 mg per kg. So we can multiply 13 by 20 mg per kg, which gives us 260 milligrams. And then, of course, we know that we have a 200 milligram per mil solution. So we're going to take our milligrams, our 260 milligram dose, and divide that by 200 mg per mil. And that equals 1.3 mils is how much we'll need to administer. That's it for now, and then we will carry on henceforth.